Welcome to this demonstration video where we will explore the critical role of earned value management, or EVM, within the context of program governance. After watching this video, you will be able to describe basic EVM concepts and how EVM integrates scope, schedule, and cost to evaluate project performance. Explore the connection between EVM and program governance, focusing on key areas such as decision-making, risk management, and continuous improvement. Calculate and interpret EVM metrics to assess project health, track progress, and predict future performance. EVM integration into program governance strengthens your ability to manage performance and aligns program outcomes with organizational objectives. EVM also helps you identify variances early, enabling proactive risk management and ensuring program success. Through EVM data, you can apply continuous improvement initiatives as they highlight areas where performance deviates from the plan. This allows governance bodies to implement lessons learned and refine processes. Additionally, EVM ensures compliance with organizational and regulatory requirements for performance reporting. By mandating regular reporting of EVM metrics, governance frameworks track progress and ensure accountability. The integrated approach to EVM and program governance is essential for delivering successful outcomes in today's complex project and program environments. Let's review a demo on how EVM, or Earned Value Management, works. We will begin by defining some key terms. Note the table to the right. Earned Value Management, sometimes referred to as Earned Value Technique, is a method used to determine the scope, budget, and schedule of a given program or project at a given point in time. EVM does indeed support program governance requirements. Budget at completion is BAC. This is the total approved project budget. PV stands for planned value. This is the dollar value of deliverables you had planned to have complete at this time in the project. EV reflects earned value. This is the dollar value of deliverables you have completed at this time in the project. And finally, AC stands for actual costs. These are the actual costs incurred to support the project to date. Now let's turn our attention to an illustration on the table to the left. We begin by documenting the BAC, PV, EV, and AC. Our BAC is $100,000. This is the total program or project budget. PV is $50,000. PV is an estimate of how many project or program deliverables we had anticipated to be complete by this point. EV is $55,000. This is a percent complete calculation. At this point, we have completed the equivalent of $55,000 in deliverables. Finally, AC is $60,000. This is simply the amount of our program or project budget we have used at this point. Now, let's review some key calculations. CV stands for cost variance. It is calculated by subtracting AC from EV. In this illustration, $55,000 minus $60,000 equals minus $5,000. We are behind on budget. We have completed $55,000 in deliverables. We actually spent $60,000 of our budget to complete $55,000 in deliverables. We are $5,000 behind. SV stands for schedule variance. It is calculated by subtracting PV from EV. In this illustration, $55,000 minus $50,000 equals plus $5,000. This is good news. We had planned to produce $50,000 in deliverables up to this point. We actually produced $55,000. We are ahead of schedule. As a summary, CV and SV calculations that are negative show we are behind. Calculations that are positive show we are ahead. Now let's turn our attention to CPI. CPI stands for Cost Performance Index. To calculate, we divide EV by AC. In this illustration, $55,000 divided by $60,000 equals 0.92. Always round CPI to the nearest hundredth. In this case, we confirm we are behind budget. We are producing 92 cents of value for each $1 we spend. SPI stands for Schedule Performance Index. To calculate, divide EV by PV. In this illustration, we validate the fact we are ahead of schedule. $55,000 divided by $50,000 equals 1.1. Again, round to the nearest hundredth. We are progressing at 110% as compared to our original schedule. As a summary, CPI and SPI calculations that are less than 1.0 show we are behind. Calculations that are greater than 1.0 show we are ahead. EAC stands for Estimate at Completion. To calculate, we divide the BAC by the previously calculated CPI. In this illustration, $100,000 divided by 0.92 equals $108,696. EAC shows how much the program or project will actually cost when complete if nothing changes. VAC is Variance at Completion. We subtract the EAC from the BAC. In this case, $100,000 minus $108,696 equals minus $8,696. This is the cost overrun at the end of the project if, again, nothing changes. In summary, this project is over budget. However, it is ahead of schedule. The team must try to reduce costs through the remainder of the project. In this video, you learned EVM integrates scope, schedule, and cost measures to evaluate project performance and progress, providing you with an objective measure of work accomplished. EVM strengthens your program governance by aligning performance management with organizational objectives, supporting decision-making, proactive risk management, and continuous improvement. Key EVM metrics include cost variance, schedule variance, cost performance index, schedule performance index, estimate at completion, and variance at completion. By understanding these metrics, you can track project health with positive or negative values indicating if the project is ahead or behind schedule and budget. You can put EVM into practice by understanding how to calculate and interpret EVM metrics, which are critical to effective program and project management and ensuring successful program outcomes.